In last chapter, we have studied atomic spectra, which was nothing but a single atom and its spectra, its energy levels. We have studied Zeeman effect, anomalous Zeeman effect. So here in this chapter, chapter 7, molecular spectra, we will study molecule. We all know molecule is nothing but a multi-atomic system. Okay, two or more atoms are there. So molecules have also the same energy levels, or we can say energy levels as like atoms. Okay, so they also have energy levels because they are multi-atomic system. They also have energy levels. Now, so these energy levels are more complex, but here these energy levels are more complex than atomic spectra, okay, or atomic energy levels, because here we have two atoms, okay. So why these energy levels are more complex? We can see here we have two atoms. Let's consider a diatomic molecule for our simplicity. So just consider this diatomic molecule. So we know it can go in its excited state. We know the electronic excitation. Okay, so it will go to first. Its electrons will absorb that energy, photon energy, and go to higher energy level. So this is a simple electronic excitation. Okay, so electrons get excited in this case, but this, as we can see here, it is a diatomic molecule, or it is a molecule. It can rotate about its axis of rotation. Okay, so here comes another constituent, another part of your total energy level. Okay, total molecular energy level. So this part also contributes to the net energy of that molecule, net energy levels. Okay, so molecular energy levels. Also there is vibration. Okay, we can see it. You can show it here like this. So these two molecules, these two atoms of molecule can vibrate. Okay, about a single point. So they can vibrate. So these vibrational energy levels also contribute to the net energy levels. So now electronic excitation, also the vibrational energy levels, rotational energy levels also contribute to the molecular energy levels. As the energy levels are complex, the molecular spectra is also complex. So this is the main difference between atomic spectra and molecular spectra. Here we get electronic spectra, vibrational spectra, rotational spectra. Now we know to the resultant molecular energy levels, we have three constituent parts, right? First, rotational energy levels, second, vibrational energy levels, and third, electronic energy level. So these are the three energy levels which are contributing to the net molecular energy level. Okay, so these are the constituent parts. So these are the main constituent parts. Now we can show the energy of the state in terms of these energy states or energy levels here. First one, electronic, let's take rotational energy ER plus then vibrational energy EV, then our electronic energy state E. Okay, so this is a complete energy of that particular molecular energy state or energy level, and these are the constituent parts. Here we have the order for these energy levels. First, biggest one is obviously electronic energy state, then less vibrational energy, and then this one rotational energy. Okay, so electronic energy, vibrational energy, rotational energy, and this is the order here. Okay, so in any molecule these energy levels are there. So if it is only rotational energy, or it is a spectra due to only rotational, or we can say transition between only rotational energy levels, then it is said to be pure rotational energy. Okay, or pure rotational spectra. I mean, it is this. Now, if molecule absorbs energy or emits energy, we know it gives us a spectra. Now, if the spectra is the energy levels, or the spectra given is pure rotation, purely rotational, when we will say it is purely rotational, when we will say that spectra given by the molecule is purely rotational. So when the molecules, the transitions inside that about that molecule occur between rotational energy levels only. Okay, these are rotational energy levels. Okay, when that molecule undergoes transition between only rotational energy levels, then that spectra is called as pure rotational spectra. Purely or pure we can say, as stated in your notebook. Okay, so this is a pure rotational energy rotational spectra. Similarly, if a molecule undergoes only vibrational energy levels, the transitions are only vibrational energy levels, only between vibrational energy levels, then it is called pure vibrational spectra. And the third one, obviously, our pure electronic spectra, we know if the transition is between electronic energy states, these are electronic energy states, then that spectra is called as pure electronic spectra. So these three, you can say these three, 1, 2, take this as a 3. So these three are rotational spectra. First one is rotational spectra, second one is vibrational spectra, third one is electronic spectra. All are pure. Okay, only single energy states are contributing. Here only rotational energy states, here only vibrational energy states, and here only electronic energy states. So if a molecule undergoes transition between rotational energy levels only, it is called pure rotational spectra. If molecule undergoes only vibrational energy levels or vibrational transitions, it is called pure vibrational spectra. And the third one, if it undergoes only electronic energy or electronic transition in between electronic energy levels, then it is called pure electronic energy or pure electronic. So the next point is molecular bond or the formation of molecule. So let's take this first point, molecular bond or formation of molecule. Okay, if we take two atoms together, in this chapter we will only consider mostly a diatomic molecule. Okay, because it has a simplicity. Okay, we will better understand the concept using only two atoms. Okay, this is also a molecule, so we will use only diatomic molecule. If we combine these two atoms, if we get them close together, enough close, so they can form a molecular bond. So we know first one is covalent bond. Okay, covalent, nothing but sharing of an electronic pair. So sharing of a pair, we know if we draw a diagram, let's draw here. Consider these two as a nucleus and electron. Electrons are moving like this. Okay, so these two electrons are shared by these two atoms. Let's say, obviously it is H hydrogen. Okay, so it is hydrogen molecule H2. So with one proton, one electron, one proton, one electron, they are sharing the electronic pair in between them. Now what happens in covalent bond? Here, these two electrons, if we see this diagram carefully, these two electrons will spend more time in this region. Okay, so more time in this region than any other region. So these two electrons will spend more time in this region. That will create a negative charge here. Okay, most negative charge, and obviously here is positive. So these charges will attract together towards each other. Okay, here. Now this bond forms. Okay, did you understand how this bond works? So here excessive negative charge at the center where the sharing is happening. So because we have the electrons spending more time in this region. So this is a molecular bond. Covalent bond. Now the second type of bond is ionic bond. You know this ionic bond. A classic example of ionic bond. Let's take NaCl, sodium chloride. So we know sodium has 11 electrons. Okay, 11 electrons, and chlorine has 17 electrons. So this excessive electron, the sodium transfers it to the chlorine, and sodium becomes positively charged, and chlorine becomes negatively charged. So these ions, actually not these atoms, actually their ions combine together to form the sodium chloride bond, ionic bond, this molecule. Okay, so we know this. It is so simple, very simple. We know it from previous standards. So now the third case is very important. Now what happens when we take these two atoms very close to each other, or we give them a high energy? Okay, so these atoms will go to a higher energy levels. So that energy will be very high, so that any molecular bond cannot survive there or cannot form there. So no bond formation will occur. We know if we want to create or we want to combine a molecule, we want to form a molecule, we have to get the energy out of it, because the two atoms are, if they are individual, they are at higher energy level. If we want to fuse them together or form a bond between them, we have to take out the energy. Okay, so this system is less energy, minimum energy, and it is more stable energy, more stable state, which is nothing but a molecule. But what happens when we give extra energy to that molecule? So its constituent atoms will go in higher energy state, and they will repel each other. So no bond formation will happen. Okay, so that's the case, because higher energy state or higher energy, more energy, instability is there. So it cannot form a bond. So we have to take out that energy to form a bond. So this is about molecular bond, covalent bond, ionic bond, and the third case, no bond formation. Okay.